Thank you for checking out this video. You are with Coach Deathbot from 32 Academy.
Okay, moving on, question 6. ABC is a triangle with the length BC, let's say, is equal to A, the length of the side AC is equal to B, and the length of side AB, let's say, is equal to small c. Okay, and assume that it's given that 3a squared plus 3b squared is equal to 5c squared. The question asks you to find the value of this expression. Alright, so cotangent A plus cotangent B over cotangent of angle C. Okay, let's try this trigonometry question. Okay, so cosine rule. Okay, cosine rule will give you cosine angle C is equal to a squared plus b squared minus c squared over 2ab, right? So here is basically just using cosine rule. Okay, next, from here, okay, it's not hard to see if given this thing. Okay, so you can change a squared plus b squared to become, so you can change a squared plus b squared to become 5 over 3 c squared, and then substitute it in. So 5 over 3 minus 1 of c squared, so that will be just 2/3 c squared over 2ab, okay? And that is equal to c squared over 3 will bring down is b. Okay, here, to continue from here, I will just write as 1/3 c squared over ab. Using sine rule, the ratio will be the same, right? So c will be facing angle c, right? So that will be sine square of angle c. A will be sine of angle A, and B will be facing angle B, so it's sine B. Okay, so this inequality is basically due to sine rule. Okay, so if you have a sine square c here. If I put one of the sine c to the left hand side, meaning I would have cosine c over sine c. Right? This is 1/3. I take one out, so now I just sine c over sine A sine B. Okay, so here cosine over sine, that is technically just cotangent of c. Okay, so 1/3, do not touch it. Sine of angle c can be written as sine of 180 minus c, right? And because ABC is a triangle, so 180 minus c, that would be just a plus b. Okay, and the denominator remains the same. Let me write in front. So 1/3 sine A plus b, I use sine of the sum of angles, correct? So that would be sine A cosine B plus sine B cosine A. The denominator is the same, sine A sine B. Okay, 1/3. If I break it into two fractions, so sine A and sine A will cancel out. Just leave me with cosine B over sine B. So that's cotangent B. The second denominator, the second fraction, sine B and sine B will cancel out. So it just leaves me with cosine A over sine A. So that is cotangent of angle A. So from here, it is not hard to see that cotangent of A plus cotangent of B over cotangent of C will be equal to 3, and that is exactly what the question asks. Okay, so the final answer will be 3. Okay, moving on, question 7. It is given that A, B, C are positive real numbers with the condition that their product is equal to 1. The question asks what is the least possible value of this expression. 2014 over A cubed times B plus C plus 2014 over B cubed plus multiplied by C plus A plus 2014 over c cubed multiplied by a plus b. So notice that all the numerator is 2014. So you can just ignore that, right? As long as you can find, because you can take 2014 as a factor. Okay. So maybe let's say I have a function f depends on 3 inputs a, b, c. I let it equal to 1 over a cubed b plus c, 1 over b cubed multiplied by c plus a, plus 1 over c cubed a plus b. Okay. It's not hard to see that f, if I take a, b, c, are all 1. So it just basically 1 over 2, 1 over 2, 1 over 2, right? So it's just 3 over 2. Okay. So we want to show, okay, we will show that whatever a, b, c is, right, the function will always be greater than or equal to 2 over 3. Okay. Such that for all a, b, c, now to be precise, for all positive a, b, c, with the condition of the product is equal to 1. Okay, so first thing first, I do the change of variables. So let x is equal to 1 over a, y is equal to 1 over b, and z is equal to 1 over c. So because a multiplied by b multiplied by c is 1, x multiplied by y multiplied by z is still 1. Okay. So f, a, b, c, instead of writing the in terms of a, b, c, okay, substitute x, y, z in. All right, you will get x cubed yz over y plus z. This is for the first fraction, and the second fraction and the third should be similar. Okay, cube zx over z plus x, and the third fraction is z cubed xy over x plus y. Because x, y, z is equal to 1, that means here it's just equal to x squared over y plus z, y squared over z plus x, and z squared over x plus y. This thing can be written further into x squared over, okay, this is gonna be a long expression, so let me write a bit in front, x squared over y plus z. I introduce this term, okay, don't forget to minus it back, and here I introduce this term z plus x over 4, the last one. Similarly, I introduce plus x plus y over 4. Okay, so I need to minus this back, and minus this back. So I need to minus x plus y plus z over 2. Okay, what's the reason of doing this? Next, I apply AMGM. So AMGM for these two, it will be greater than or equal to 2 times square root of these fractions multiplied together. You cancel y plus z out, right? So under the square root is x squared over 4 coming out of the square root. So x over 2 with the 2 outside. So this will just be greater than or equal to x. From here is basically just use AMGM inequality. Okay. Similarly for this one, that will be y, and this one will be greater than or equal to z. Okay. And the last, do not do anything. Okay. Due to AMGM inequality. Simplify this will be just equal to x plus z plus x plus y plus z over 2, which is greater than or equal to 3 over 2 cube root of x, y, z. The reason being because I know the value of x, y, z. All right, and this is obviously just equal to 3 over 2. So no matter what it is, as long as x, y, z, the product is equal to 1, this function will always be greater than or equal to 3 over 2. And we know that 3 over 2 is actually attainable as when you use a, b, and c are all equal to 1. So that means that hence the least possible value of f, a, b, c is basically 3 over 2. The question asks for 2014 of that. So basically the answer would be just equal to 2014 multiplied by 3 over 2, and that will give you 3021. Next, question 8. It is given that w, a, b, and c are positive integers with the constraint that w factorial is equal to a factorial plus b factorial plus c factorial. The question asks for, with this condition, okay, the question asks for what is the largest possible value of the sum of w, a, b, and c. Okay, the largest possible value of the sum. So without loss of generality, okay, WLOG, without loss of generality, we can assume, or we may assume that this is symmetric around A, B, C. So assume that A smaller than or equal to B, smaller than or equal to C. Okay. It is easy to see, or it is clear to that omega W is greater than or equal to C plus 1. Okay, just from this fact. It's not hard to see. Alright, so that C plus 1 multiplied by C factorial, that is basically just C plus 1 factorial, alright, is smaller than or equal to, right, because C plus 1 is smaller than or equal to W. So C plus 1 factorial will be smaller than or equal to W factorial. Okay, and yep, that will be equal to A factorial, B factorial, plus C factorial. This is exactly just from the question. We assume that C is the maximum among the three, so this would need to be smaller than or equal to 3C factorial, right? Because A factorial need to be smaller than C factorial. Same thing for B factorial, and of course C factorial is equal to C factorial. Add them up, it must be smaller than or equal to 3 factorial. So this is smaller than or equal to 3 factorial. 3 multiplied by C factorial. Cancel the C factorial. So C plus 1 smaller than or equal to 3. C is smaller than or equal to 2. So the maximum need to be 2. Okay. So A and B can be just 1 or 2. Alright. So it is not hard to check. It is easily checked that A is equal to B is equal to C is equal to 2 with W is equal to 3 is the only solution. Okay, so this is the only solution, the rest does not work. So that means, hence, answering the question asks for the sum, right? So W plus A plus B plus C would just be 3 plus 2 plus 2 plus 2, and that would give you a value of 9. Okay, moving on, question 9. Let's read the question together. A real valued function f satisfies this relation. So f of x squared plus x plus 2 of f of x squared minus 3x plus 2 is equal to 9x squared minus 15x. So this is called functional relation. Okay, for all value of x. Okay, the question asks you what is the value of f of 2011. Okay, let's try. So this is the functional relation. It is given in the question. Okay, let's just say one. Notice that if I replace, it is true for all x, right? So if I replace x with 1 minus x, so this functional relation would be whatever x, I need to replace with 1 minus x, alright? Plus 2f of 1 minus x squared minus 3 1 minus x plus 2 equal to 9 1 minus x squared minus 15 1 minus x. After some simplification, you would get f of x squared minus 3x plus 2 plus 2f of x squared plus x, and the right hand side can be simplified to 9x squared minus 3x minus 9. Let's say that is the second equation. You focus on these two, okay? Equation 1 and equation 2. The same, right? So if I want to eliminate one of them, so let's say I want to eliminate f of x squared minus 3x plus 2. So all I need to do is I just need to take 1 minus twice of 2, right? So this will give me 3f x squared plus x, and the right hand side is, after you simplify, you should get this divided by 3 on both sides. You will get 3x squared plus 3x minus 12. Notice that the input is x squared minus x. It is not hard to see that this can be written as 3 x squared plus x minus 12. So that means that, right, hence f of 2011, meaning that x squared plus x is equal to 2011. There will be some value of x that make it equal to 2011, and this will be 2011, right? So 3 multiplied by 2011 minus 12, and that will be divided by 3, so this is negative 4. So sorry for that, and this is negative 4. Same thing, this is negative 4, right? Because you divided by 3 from here to here. Okay, so this will give you the final value of 6029. Okay, last but not least, question 10. Determine the value of this expression. So it's a limit when n approaching infinity of summation, alright, of I starting from 0 all the way until n of 1 over n choose I. Okay, so this is not a fraction. Okay, this is a basically n choose I is combination. So that is n factorial over I factorial multiplied by n minus I factorial. Okay, so yep, it's a limit when n is approaching infinity. Right? What will this thing become? Okay, let's try together. So first thing first, notice that this thing, okay, I let a is equal to that. So let's say an is equal to summation of I starting from 0 all the way until n 1 over that. So I can write it as power negative 1. Right? Same thing. So for n greater than or equal to 3, okay, I mean n is going to infinity anyway. Okay, so for n is greater than or equal to 3, notice that an can be written as summation of I from 1 all the way until n minus 1 of n choose I. to the power negative 1. So still something else, right? Because it needs to be from 0 all the way until n. Okay, but this summation that I just wrote here only from 1 all the way until n minus 1. So meaning I still miss out the term where I is equal to 0 and I is equal to n, right? So when I is equal to 0, meaning that is n choose 0. N choose 0 is 1. 1 to the power negative 1 is still 1. N choose n to the power negative 1. N choose n is 1. Again, this is just 1. So 1 plus 1 is 2. Okay. Let me delete this. You can pause the video to see the writing. Alright. So here is this obviously is a positive number. So it is not hard to see that this is greater than 2. Also, know that an is equal to 2 plus, again, this thing. If I only start from 2 all the way until n minus 2. What am I missing? I missed the term when I is equal to 1 and I is equal to n minus 1, isn't it? Alright. So when I is equal to 1, that is n choose 1 to the power negative 1. N choose 1 is n. So n here, and n choose n minus 1 to the power negative 1. Again, it's also n. Okay. So n to the power negative 1 plus n to the power negative 1, that is just 2 of that. So it's just 2 over n. Alright. Okay, again, let me delete this. You can pause the video or can just rewind the video to see what did I wrote here. What did I write here? Okay. Keep it like that first. Since n choose I is always greater than or equal to n choose 2 for all I with basically I is in between 2 and n minus 2. Okay, binomial coefficient, right? It's like it should be in this form. Okay, the more I in the middle, right? The closer I to n over 2, the higher the value it is, right? And that means you notice that we are considering from, let's say, 2 all the way until n minus 2, right? So whatever in between, the combination will be higher. So it's greater than or equal to. Okay. So here, that means that an is smaller than or equal to 2 plus 2 over n. This thing, right? Because each of the term is greater than or equal to n choose 2, but because it's to the power negative 1, right? So each of the term will be smaller than or equal to. Yeah, the sign would change. N choose 2 to the power negative 1. And how many terms are there? From 2 all the way until n minus 2. So that is n minus 3 term. Alright. Smaller than or equal to. Do not change the first two terms. Okay. N, let me write here. N choose 2 to the power negative 1 multiplied by n minus 3, right? That is equal to n minus 3. N choose 2 is n minus 1 over 2. So this is basically 2 over n minus 1. Okay. And this is obviously smaller than or equal to 2 over n. Alright, because this is smaller than or equal to 1. Okay, so plus 2 over n. Okay, and that will equal just this. Right. So far, what do we notice? Okay, just in case you lost track, I have established that an is greater than 2. So somehow there's a little lower bound. We also established that an is smaller than or equal to 2 plus 4 over n. Okay, so let me write down together. So 2 strictly smaller than an, and that is smaller than or equal to 2 plus 4 over n. Okay, so it is not hard to see that when you put limit and go to infinity, limit and go to infinity, limit and go to infinity up to 4 over n. So obviously this is still a 2. This is what we want. Okay, notice that this is limit. Alright, so this is smaller than or equal to and go to infinity, so this is 0. Alright, so this will be just 2. So that will squeeze limit and go to infinity of an to be 2. And that's exactly what the question asks. We have completed this lesson. Thank you for watching this video. I hope you have enjoyed today's lesson. Goodbye and see you again in another lesson.
If you would like to learn more from these tutorials, please smash that like and subscribe button.